Now we're going to take a look at the period of cosine of x. We're going to revisit it and figure out what the period of any cosine function is when you introduce a new number in front of x. So again, this is the original cosine of x, and we can see that it takes a distance of 2 pi. So if I take this and move it down, I can see that it takes 2 pi to get from the top of, or the crest of one wave to the crest of another. We said before that you can measure any 2 points on the graph, and the graph you can still see how the graph repeats itself. So for example, at the middle of the waves, it still takes a distance of 2 pi for the graph to repeat itself. And we said that is the definition of period. We're going to do a proof like we did for sine to figure out the period of any cosine function. So for now, the original cosine is the distance between 2 pi and 0, which is the absolute value of 2 pi minus 0, which is 2 pi. In this case, the y values are 1 instead of 0, but again, it doesn't have to be the y value of 0. It just has to be where the graph repeats itself, where the y values equal each other, and where the graph begins to repeat itself, meaning the cosine value. And that leads us to go back to the unit circle. We can see that the period of cosine is also 2 pi, because if we look at the x values, starts at 1 and goes to square root of 3 over 2, okay, and then they become negative in the second quadrant, right? Now, the x values do not repeat themselves at pi, because the new x value is negative 1 at pi, not 1, and they become negative in the third quadrant. If they repeated at pi, they'd go back to being positive like they were in the first. So it takes all the way until you go through the fourth quadrant before the x value becomes the same, 1, and every x value after that will be the same as if you started at 0 pi. Now that you're at 2 pi and you go on, the x values will be the same. So the period of the regular cosine function we can see is also 2 pi at the unit circle. So how do we prove cosine of bx? What if we put a number here? Well, first of all, this is just some more showing of why the difference between these two x values, they get you the same y value where the graph repeats itself. The distance between them is 2 pi. So if I make b anything for cosine, how can I figure out the period? Well, it's going to be the same exact thing we did for sine. If I plug in 0 for x, I'm going to get a y value. I'm going to get cosine of 0, which we know is equal to 1. So the first point would be 0, 1. Now if I have a b here, if I put a b here in front of the x, and I strongly recommend you watch the sine video before you watch this one, because I went into more detail. In order to make sure the graph repeats itself, this bx must be equal to 2 pi, because cosine of 2 pi equals 1, and that's where I can guarantee that cosine is going to repeat itself. The cosine values are going to start to be the same again after 2 pi. So I'm going to set bx equal to 2 pi just like I did in the sine proof. B's cancel, and I get x equals 2 pi over b. And my original x value was 0. My new x value is 2 pi over b, and that guarantees the same y values of 1, and that guarantees that the graph will repeat itself, because cosine repeats itself at 2 pi. Therefore, my period is the difference between these two x values, 2 pi over b minus 0. The distance between that would be the absolute value of 2 pi over b. Now again, if I wanted to plug in, so again, plug in 0 for b, I get cosine of 0, which is 1. If I were to plug in 2 pi over b back in for x, the b's are going to cancel. I'm going to get cosine of 2 pi, and hence again that guarantees the y value is 1, which is my starting y value at 0. Therefore, the period is the distance between 2 pi over b and 0, which is the absolute value of 2 pi over b. And finally, for any function g of x where it equals cosine of some number bx, as long as if my starting x value is 0 and my next x value is 2 pi over b, this will guarantee the same y values of 1 and that the graph repeats itself. And my period is the distance between these x values. Going back to the graph, just so you can remember what that looks like, it's the second x value minus the first x value gives you that distance, or just subtract them both. So you could do 0 minus 2 pi and just take the absolute value. Either way, you get that distance of 2 pi. So The distance between these would just be the absolute value of 2 pi over b. That's pretty much it for this video. I do want to go over the some different cosine periods. So let's change this b value, for example, make it bigger. Let's make it 4. So if we do 2 pi over 4, that would be pi over 2, right? Right? If b is 4 and we want to do 2 pi over b, it'd be 2 pi over 4, which is pi over 2. In fact, I will show that. Okay, so the period is absolute value of 2 pi over b. If I make b equal to 4 and plug in 4 for b, I get the period of pi over 2. Let's see if that works visually. Well, the crest of the wave starts at 0, goes down and comes back up, and voila! It repeats itself at pi over 2, meaning the period would be pi over 2 minus 0, which is just pi over 2. So as I change this b value, I can use that formula of the absolute value of 2 pi over b to figure out the period of any cosine or sine function. It's always going to be the absolute value of 2 pi over b. Next up, we'll do some more examples. If you have any other questions about this video, let me know.